Okay, so people in class here, you have this set of notes, and then underneath it you have the notes you'll need for tomorrow. Guys at home, you should have received this on Friday. If you didn't, check your OneNote folder if you need to, or you could just jot things down on loose leaf and then fill it in when you get the hard copy tomorrow. But here we go. One-sided limits. Oh, hang on. I need the pen. Okay, so we know that when we look at that function f of x, that the function f of x does not exist at x equals 2. Or in other words, f of 2 would equal undefined. And why would f of 2 be undefined? Oh, for the reason it almost always is, because you can't divide by 0 when you're doing any kind of math. So what if we approach it from the left? So what if we approach this hole in the graph, this, we're going to use the fancy new word, this discontinuity in the graph. What if we approach it from the left? Okay, I've already run the numbers for you. And I've shown you how I do that. I don't sit there and punch buttons on my calculator over and over again. I just make a quick little Excel file. And I got 3, and then I got 3.5 for 1.5. Then when x was 1.9, I got 3.9. Then when x was 1.99, I got 3.99. So it seems pretty obvious, and it's sort of obvious from the picture too, that we're definitely approaching the value 4. But to be sure that that's the value, we also approach it from the right. So from the right, when x is 3, the value of that function is 5. When it's 2.5, I get 4.5. When it's 2.1, I get 4.1. And when it's 2.01, I get 4.01. So there we go. There's all of the evidence I need to conclude for myself that hang on, I'll write conclusion. Conclusion, as x approaches 2, f of x equals 4. And I can drop the pretense of saying, well, it's approximately 4. Remember, our very first conversation in this course was that 0.9 repeating is the same thing mathematically as 1. So infinitely close to 4 is 4. We have decided. Okay? Writing this down in the notation that we're going to be getting used to from now on, we're going to say the limit as x approaches 2 of x squared minus 4 over x minus 2 is equal to 4. And of course now we actually have a algebra way we could have figured this out without doing the graphing. And this is where I didn't really give you room for this. Okay, I'm just going to pause the video while we do O Canada. Okay, and we're back live again. Come on. We can, of course, do this algebraically. Right? If we plug x is 2 into the function, into the function f of x equals x squared minus 4 over, it was x minus 2, right? Yep, over x minus 2, then we get division by 0. But if we are looking for the limits as x approaches 2 of x squared minus 4 over x minus 2, we can use factoring to show us that we can write an equivalent expression to our original expression that doesn't have an